The last couple of lectures, I explained it about the operation of synchronous exception due to memory overt. So in this section of the lecture, I'm going to cover the synchronous exception due to SVC instruction. Before I look into the details of synchronous exception due to SVC instruction, and let me go through the overall workflow and operation in the big picture. As you know, there are main two causes of synchronous exception. The first cause of synchronous exception is memory overt. And second category of causing synchronous exception is system call. So in each way, synchronous exception occurs due to system call when the SVC instruction is executed, and then synchronous exception is generated. So from now on, I'm going to explain about the workflow or detailed operation of synchronous exception due to SVC instruction. In order to understand the synchronous exceptions due to SVC instruction, we have to look up the details of operating system and ARM architecture together. And sometimes it is important to look at the operation with the big picture. So here, EL0 stands for exception level 0, and EL1 stands for exception level 1. As you know, user application is running at exception level 0. Which software is running at exception level 0? Generally, user application like YouTube, Chrome browser, another application you can install in your mobile phone is running at exception level 0. But user application running at exception level 0 can have limited privilege mode level in Armv8 architecture. So what is privilege level in Armv8 architecture? Access to the memory space or ability to configure the specific register is considered the privilege level. But sometimes the user application are in the situation to access the hardware resource directly. In this case, system call should be invoked to request the service to the kernel space. For this, system call is invoked. But if we go look into the implementation of system call in more detail, you will find out that system call is implemented using the feature of CPU architecture. In case of Armv8 architecture, SVC instruction should be executed to perform the system call. So in order to understand system call in more detail, understanding of synchronous exception using SVC instruction is very important. What happened as SVC instruction is executed? Then ARM core will generate synchronous exception, and then will branch to specific address. That address is called exception vector address. After the assembly instruction at exception handler is performed, it will call system call handler using system call number. This is the basic scenario of system call in the Linux operating system. So if you understand the how synchronous exception is taken care of by Linux kernel, we have to know about operation and workflow with the big picture.